series that looks sort of like a geometric series, and I'm just going to write down, like for I equals 0 right here, this gives you the first term. If I is equal to 0, you get 1, and you can check that. I is equal to 1, you get 6 over 9. I is equal to 2, you get 11 over 81. I is equal to 3, you get 16 over 729. And again, that's not hard to verify just by putting I equals 0 in here and writing down I just wrote down the first 4 summands here. Okay, so again, I equals 0, that's the particular summand. I equals 1, this is the summand. I equals 2, summand. I equals 3, summand, right? So you get from one to the next. 1/9 times this gives you the 81, but it doesn't give you the 11. So we don't have a common ratio right here, but it turns out we can do an algebraic manipulation to get a common ratio. Now the idea here, and I hadn't seen it before, I saw this on an SMO preparation sort of resource, but if you multiply this by 9, notice how you get a constant here, 9 plus 6, and you get 11 over 9, and then you get 16 over 81. And you're going, well, why did you do that? Because this is still not a geometric series the way it's written, right? 1/9 times this certainly isn't that, okay? But the real trick here, and this is kind of cool, I like this. This part right here is 8s is, of course, simply 9s minus s, right? 9s minus s is certainly 8s. Now you're going, so what? Well, if you notice, you get 9 plus 5 here, or it's 9 plus 6 minus 1 is 9 plus 5, and you see how these 5s are hanging around, okay? That's the motivation behind this. That's 9x minus s is equal to this 8s you see right here. But the benefit of doing that is you get a geometric series after you factor a 5 out. If you guys, isn't that cool? I thought it was super slick. In other words, 9 plus 6 minus 1 is 9 plus 5 that you see right here, right? And then when you subtract 6/9 from 11/9, you get the 5/9 that you see right here. When you subtract 11/81 from 16/81, you get 5 over 81. That is so cool. I mean, that's just a little trick here. And so what you get right here, you take the 5 out. You take the 5 out of this, of the group after 9, right? Out of these 3 terms. And so what you end up with here is a geometric series with r is the common letter here. R is equal to 1/9. Okay, r is equal to 1/9 in the parenthetical expression right there. And you do have a geometric series, an infinite geometric series inside the parenthetical piece here. Okay. Now, a lot of you probably recall this result right here. The geometric series here, this is the compact form for it, is 1 over 1 minus r, provided the absolute value of r is less than 1. Well, absolute value of 1/9 is certainly 1/9, which is less than 1, right? Okay. And so we actually get, in this particular case, this 9/8 that you see right here, okay, that's actually came from this formula. The first term is certainly 1, right? And so you have 1 over 1 minus 1/9, okay? And of course, this is 1 over 8/9. 1 over 8 over 9. One over 8 over 9, folks. And of course, well-known truth from geometry, you just invert this. And that's exactly where the 9/8 comes from, right? Okay. And so what we get, let me just write it out. This is the final part right here. 8s, we see that 8s, not s, but 8s is equal to, that s hopefully doesn't look like a 5 to you guys. 8s is equal to 1/17 over 8. Okay, that's the result of this, all this work here. You have equals, a string of equalities here, equals, 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 right? And so, of course, dividing by 8 results in the solution to this. S is equal to 117 over 8 squared, which is 64, right? So that's what I got at least. 117 divided by 64. Okay, that's the solution, folks. 117 over 64 is what the original series up here, I'll just write it up here again for y'all if you need to see it. So this is equal to 117 over 64. All right, hope you guys enjoyed. The nuggets are going to crush the heat.